In this video, I'll be taking apart and going over the Anker Prime 160 watt smart display wall charger, the world's most compact 160 watt multi-port power charger, delivering a power density of 1.35 watt per cubic centimeter. As always, links are in the description. This compact wall charger by Anker provides a total of 160 watt output amongst the 3 USB-C ports. There's a glossy finish panel on the front where the display and touch capacitive button are, and the rest of the housing is a gray or silver metallic colored plastic. It has prongs which go into the power outlet, which unfold out and can be folded back in again to easily store, keeping it nice and compact. Any single port can output up to 140 watts. When plugged in, the display powers on and gives you useful information on total power output, as well as power output levels for each port. You can also monitor temperature levels, change charging modes, which is done through the app, as well as connect the app via Bluetooth. Another neat feature it has is it allows you to flip the display orientation by triple tapping the button, so the display can be upright depending on how you have it plugged in. Whether it's on the wall or on a power strip, you won't have trouble reading the display or plugging your cables in with the design of this charger. Using the app, you can update the firmware, making sure it's running smoothly at all times and with the latest features. Diving in further, we're also able to see charging speeds of each port with real-time data, enable or disable specific ports, as well as change charging modes. For charging modes, there's AI Mode 2.0, which automatically distributes power to the ports depending on the needs of the devices plugged in, Standard Mode, which has a fixed distribution making the C1 port the priority port, and Custom Mode, which allows you to specifically allocate output per port based off what you want. So this wall charger isn't just an ordinary wall charger. It takes it to another level with the smart features. Now let's take it apart and have a look on the inside to see how it's put together. When it comes to power banks or wall chargers, they aren't generally designed to be opened up. So the housing is made in a way that it's glued together. So taking it apart means prying it open or breaking open the housing. Once this cover has been pried off, we can see that there are 4 Phillips screws, which are holding the charging prong assembly to the plastic housing. These metal pins or points touch and make contact with these metal pieces here. With that cover also being removed, we see blue and pink thermal gel inside to help transfer heat. Now we'll need to continue cutting open the housing. So there's 3D layer of graphite, which is multiple layers of graphite, which work to transfer heat, as well as insulation tape and padding, which run around the sides and to the front of it. The flex cable for the display is located here, which connects to the board. And I obviously pulled that out when I was pulling out the assembly. There's copper film behind the button. And this is the Bluetooth antenna. So now we can see a lot more thermal gel or thermal compound in between the openings or crevices. There are also additional graphite pads to help transfer heat. Here's a look at the internals after most of the thermal gel or compound have been cleaned out. There are 9 separate boards which are soldered and put together in this very compact design. Also, there's a lot of measures taken for heat transfer as well as for insulation. Now, I'm not an expert in what every single component is, but I will mention the ones I know or I'm able to look up. From the front, we see the 3 USB-C ports, 3 solid-state output filter capacitors, and 3 step-down inductors. On this board, we can see 4 NMOS transistors, resistors, and a power control chip. From this side, we see some thin film filter capacitors, as well as filter inductors. One of 3 high voltage filter electrolytic capacitors are also visible, and from the solder points below the board, we know that there are 2 more right next to this one that is visible. On the board behind it, there are 2 PFC rectifier diodes, as well as the GaN transistors. Taking a look at this side, we can see 4 solid-state filter capacitors, another thin film capacitor, as well as 2 thermistors which measure the temperature. On this board, we see the Bluetooth module located here, with the coaxial cable connected to it. We also see the screen flex cable connector, and the coil which detects touch from the front button. These gold contacts touch the contacts on the Bluetooth antenna, which is on the housing to make a connection with the antenna. As for the transformer, I believe it's located in the center between all the components and boards. So we can see this is pretty complex, and a lot of designing went into the components used, the cooling, and the installation. I like the overall look of all these boards and components, and if there were a way they could have used the transparent design for the housing to show it all off, it would be really attractive. With that being said, I hope you enjoyed this video, and I'll see you in the next one.